Hi, welcome to Server 2012. My name is Sandra Batakis and I'll be your instructor throughout this course. Now, working with Server 2012 is always a pleasure, just seeing the new features, whether it be for network infrastructure or for all the security features. And when I reference back to the beginning of time, or so it feels like, when I got my first MCSE on DOS 5.0 and Windows 3.11, thinking that that was extremely elaborate and so powerful, it really is fun to watch the technology grow and to share it with all of you. Now here in the classroom, I'll have a chance to share all the technical knowledge and all of the Microsoft knowledge on how to get things to work together. But I will also tell you, feeding into this course, is that I have also lived in the field and continue to live in the field where I see this work from day in and day out to know what really does work and what really is not going to work. So based on that, we'll wrap it into a course and we'll get a lot of learning to happen. In this module, we'll talk about network services, specifically dig into DHCP, DNS, how they work together, and how IP address management can really manage the entire process as well. We're going to go through the definition and purpose of DHCP and DNS. Now, we do have to assume at this point that we know what the services are and the basic allocation of them, but we're really going to dig a little bit deeper into how we plan them and how we really get through the different components and exactly what they're intended. We'll then move through the lease process, different options and ways to integrate, as well as discuss superscopes and multi-netting. Moving forward, we'll also talk about our DNS solutions, how to log DNS if anything's going wrong, and we'll specifically really look at DNS security and how to deploy DNSSEC, how we look at socket pools, and of course our cache locking. When we're done with DHCP and DNS and we have a really good idea of what it takes to manage, allocate, and have name resolution, then we will move into the IP address management, otherwise known as IPAM. IPAM is going to give us an enterprise view of exactly what's going on with our IP network and monitor it as well. So the tools allocated will allow us to plan for our IP infrastructure, we'll do inventory management, we'll look at utilization statistics. So once everything is up and running, this comes in and allows us to monitor and manage the entire process. DHCP, otherwise known as Dynamic Host Configuration Protocol, is with us in order to allow us to allocate IP addresses and IP address configuration. Now, we can obviously statically assign every single machine in the network with an IP address, a subnet mask, a default gateway, some DNS servers, Win servers if they're still floating in your network somewhere, and there's a whole lot of other configurable options. Those, of course, are just the most popular. Well, to handle this statically is actually a pretty big job, and there's a lot of room for error, whether it's administrative error or whether or not it is an overlap and we have some duplicate configurations. So based on that, we use DHCP. DHCP will allocate the IP addresses and the configuration to the clients, so the clients boot up, request an address, and get one. But it also tracks who has what IP address, so that way we don't have any overlap. Now, what also helps quite well with DHCP is, let's say globally you're going to change what your default gateway is going to be, or you're going to change or add another DNS server. Well, instead of visiting every single client in the network, we can very easily go to the DHCP console, go to the scope options, add or change or remove any of those options, and the next time these clients renew, they will receive the options themselves. So DHCP allows us all of that flexibility in management and also gives us a single place for updating. We can also have reservations with DHCP, so even if something needs a static address, if we reserve it by its MAC address, it does get the same IP address every single time, but the address is actually managed from the DHCP console. So again, a way to manage things all in one central location. Now on the client side, many devices can be a client. The obvious are clients, the PCs, the laptops, the servers, the printers even, but those DHCP clients can be really any network device. So it could be your smartphone when you tap into the Wi-Fi, or it could be a switch or a network boot client. So anything that knows how to boot up and request an IP address, which is the majority of any network device, all of those can in fact be a DHCP client. Let's go through the components of DHCP server. We have the server service. Well, the server service is obviously a listening service for the client requests, but the server service also has its own client service. So a server can be a DHCP server or a DHCP client. Now, with the server service, we have the auto startup on a Windows host. So that means every time Windows boots, the server service will kick in for DHCP. And again, that's the component that will be responsible for all the IP address allocation. Another component is the DHCP database, which means we have all of the configuration data, including who has what IP address. So we have all the information regarding the IP addresses that are leased. Its default location, although you can move it, is in the system root under system32/DHCP. We also have a component for the DHCP console. Now, the DHCP console is your main administration tool. This is where you're going to view the configuration and some client information. And the DHCP console can not only be seen on the DHCP server, but you can install it as a tool on a client machine with remote service administration tools, otherwise known as RSAT. Now, if you want to remotely deploy this particular tool, it does have to be on a Windows 8 machine if you're going to use this with RSAT. We also have a component called DHCP authorization. Now, DHCP authorization means when you install a DHCP server, an enterprise admin has to authorize a DHCP server on the network. If it is not authorized, it will shut the service down and it'll be unable to answer requests. This, of course, is a security feature, so just not any administrator can create a DHCP scope, put it out on the network, and then have it actually handing out IP address, which may not necessarily be the right one. So again, it has to be authorized by an enterprise admin in the domain, or the DHCP service will shut down. And authorization is a simple step. It literally is a right-click and authorize. It just has to be done by the right person. Within DHCP, we have something called a scope. A scope is essentially a range of IP addresses and any of the related information. Now, any of the related information can be obviously the optional information, but the required. You wouldn't give out an IP address without a subnet mask, an example. So IP address and submask is going to be your minimum, but we can have a default gateway or DNS servers or all sorts of other information depending on what you need. So an actual DHCP scope has to have a scope name and description so that we know which scope is which and what the purpose is. It'll have a range of IP addresses and a subnet mask. Now again, that's all you need for a client to be on the network. You might be thinking a default gateway is a requirement, but not necessarily. Without a default gateway, clients can still communicate on the network. They just can't get out of their own subnet. Now again, the optional configurations could be anything from the duration of the lease to the DHCP options like default gateway or DNS. But we also have an optional configuration called exclusions. So if I was to go ahead and create a scope, and that scope contained 200 addresses, but somewhere in the middle was an address that was already in use by a device on the network, and for whatever reason it couldn't change, I could have a scope with a whole range of addresses, and I could exclude that one in the middle so that the printer could keep or device could keep whatever IP address it needed. Now, with the other options, there's some other options just to think about. A domain suffix. A domain suffix is what gets appended on the end of their host name. We can add more than one domain suffixes for search. So as we're querying DNS servers, we can look at more than one DNS zone, but more about that later when we talk about DNS zones. We can have WINS or NetBIOS name servers. And also with scopes, we can decide the options, but options also have different levels. An option can be global to all scopes. They could be at the scope level. We can create a class ID level, which could be hardware, software defined, or it could be at the reservation level. So if I reserve an IP address and configuration for a client, then that reservation can have its own options, its own default gateway, its own DNS servers. So we can create those options at many different levels. The default level and the most common level, of course, is at the scope. Now, you can configure more than one scope on a DHCP server, but the server has to be connected directly to each subnet that the scope is answering to, and if it's not, you'll have to deploy a DHCP relay agent in order to relay it over to the appropriate server. With the DHCP, there is a lease process. Now, the lease process, in its simplest form, is a client asks for an IP address, it gets one, and it gets it for a duration of time. So that's what's known as a lease. Now, the default lease is 8 days. We can change that to be unlimited, or we can change that to be 2 hours. It doesn't matter. So the lease process is when you get your configuration. Now, the things to remember about the configuration is there's technically 4 different stops. So the client who doesn't have an IP address, all it has is a physical address or MAC address, will send out a broadcast. That broadcast is for any DHCP server that's listening. Now, once a DHCP server hears it, they can actually send a DHCP packet back to the client. Now, it doesn't have an IP address, so it basically broadcasts it back, so it's going to hit that MAC address. So it's going back to the MAC address of that server. So the server will offer a configuration. The client will accept the first one. So we have another packet that's traveling. And then from there, the server responds with an acknowledgement, almost a final confirmation that, yes, this is going to be the information. Now, if more than one DHCP server has offered an IP address, then the rest of the servers will send out what is known as a NAC. That's NACK, or a negative acknowledgement packet, basically rescinding their offer. So once that acknowledgement is received, that client has that IP configuration for the duration of the lease, again, 8 days by default. Now, what happens with this lease process is every time the client reboots, then it's going to look for the default gateway. If it can't find it, it's going to resume the entire renewal process again, even if the lease is not up. Now, the reason for this is a lot of computers, like laptops or mobile devices, they move from network to network to network. So if you reboot it, it realizes by the gateway that it's no longer on the same network. Therefore, it's going to start the whole process again. Otherwise, if there's no reboot, or if every time it reboots, it contacts the gateway, so the lease is fine, halfway through that lease, the client will attempt to renew. This process is at 50%, and then it goes to 87.5%. And then, of course, when the whole lease is expired, it goes through the whole process again, assuming it hasn't automatically renewed. Again, so the renewal is done at the end of the duration, actually halfway through the duration, 3/4 of the way through the duration, or anytime it reboots and it can't contact the gateway. There's a lot of different options with DHCP. We can create what is known as super scopes, which are more than one scope essentially tied together. We have our multicast scopes. So instead of an IP address to a directed client, multicast allows them to actually do a one-to-many type of broadcast. We have options that are specific to DHCP version 6, and some of the other options we can configure is really more about the high availability. As a matter of fact, with DHCP finally in Server 2012, notice the finally, we have some failover components that are outstanding so that if one DHCP server fails, another one can automatically take over. So we will talk about that shortly, but for now, in general, those features have been here, and that was a whole lot of manual steps that didn't work as smoothly before, so this is actually a good thing. We have failover, we have split scopes, and we also have DHCP name protection where we can protect certain configurations for clients. DHCP does integrate with DNS. Now, DNS, in its simplest form, is taking a host name and mapping it to an IP address. So if your IP address changes all the time, it's important to have DNS always updated. Now, we do have DNS that allows not only the update of host records, but also have the pointer records and the reverse lookup records. And again, who updates it? Which records do they update, and when are those records deleted are part of some of the questions. So we have something known as DHCP Options 081. Now, 081 allows the server to actually own the DNS records. So DHCP is doing all the work on behalf of the client. It'll create the records. It'll also delete the records when the IP address expires. Now, we can also go to the DNS tab of DHCP, On the Properties node, you will see that there's what's known as a Protocol node, and here you can configure this per scope. Now, we have DHCP server that updates a DNS client. This is only if the client address requests it. It can do the host record, the pointer record. The default could only be the pointer record, and the client will actually do its host record or its A record. But upon lease expiration, the record gets discarded, and so does the pointer record. So let's talk a little bit about this thing called superscopes and the other one called multi-netting. A superscope is a collection of scopes. We group them together just for administrative reasons to make it easier to manage. The subnets have to be combined onto one logical subnet. So we know that we can take a 192.168x dot host ID, and we can subnet that out to 255 additional IP subnets. Well, we can group all of those together, but with the right subnet mask, all of them can technically be seen as one giant network. So this is what we mean by a superscope. Now, with the superscope, again, the subnets must be able to be combined into one logical subnet using a subnet address. We need 2 or more scopes that have already been created, and then we pull them together as a superscope. The superscope wizard allows you to create, it just walks you through which scopes do you want to bring together, and it always works well when you're moving clients to a new subnet and you're trying to do so transparently. Now, the benefits of this, it allows us to expand a scope if you run out of addresses, and of course the other benefit is it helps you when you're moving clients to that new subnet. We also have something called multi-netting. Multi-netting is when you actually add a second scope, and we're going to create a second scope on a different subnet. The routers will have to be configured to allow this traffic to go through, but again, it does allow you to create those other scopes. We also have a multicast scope. With a multicast scope, the first thing that we talk about is what is known as MADCAP. Now, MADCAP is technically our Multicast Address Dynamic Client Allocation Protocol, which is why MADCAP sounds so good because it's such a long name. With MADCAP, we have applications that have to support this API, and it allows us to take a collection of Class D addresses. A Class D address is outside of what we would assign to a host. It starts from 224.0.0.0, and it goes all the way to 239.255.255.255. That's what's known as a Class D address or a multicast range. So you can create multicast scopes, and we create them for applications. So if the applications have to communicate with one or more clients at the same time, again, otherwise known as a one-to-many, like a video broadcast. Multiple hosts that listen will all get the same IP address. But again, remember, a multicast address is intended for people to have the same address. Now, the applications themselves are going to have to reserve a multicast address in order to broadcast across it. And it's all about data and content delivery. Now, if you ever create the multicast scopes for video type broadcasts or PowerPoint broadcasts or any sort of those live meeting broadcasts, but even WDS. So when you have Windows deployment services can technically push out a new image to be rolled out to more than one client at the same time. So again, it's another example of a multicast scope. Most of what we've been talking about is DHCP version 4. That's the one that's been around forever. That's the one that everyone is super comfortable with. But we now have DHCP version 6, which little by little by little is etching its way into our lives. DHCP version 6 takes our simple little 32-bit address and expands it to 128 bits. So we have 32-bit in binary. We're now at 128 bits. That's in hexadecimal. Well, I know that I can look at an IP address in version 4, and it makes perfect sense. DHCP version 6, we still have to work it because it's a whole lot longer. It's hexadecimal that most people are not used to reading, and with that comes other types of configurations. The good news is there are some items that might be called something different, but it is analogous to something that we already have. So let's learn a little bit about DHCP version 6. First off, we have configurations supported. We have what is known as stateless versus stateful. When you look at a stateless configuration, we have a router that assigns the IP version 6 address automatically, but DHCP is still involved because it's only the configurations. So its role changes a little bit. We have stateful. Stateful means we're not going to get the routers involved. The DHCP server is going to act just like it has been for so many years. It's the IP address and any other configuration data. Now, the scope properties for DHCP version 6 have a name and description. That's common. We also have something called a preference. A preference is what tells the version 6 clients which server to use. So we've got a little bit of what I would call load balancing, because we're going to tell them which server to use. That's going to be in there. We have what is known as a valid or preferred lifetime, but that's really just the lease as we know it. We have a prefix. A prefix is really like an IP version 4 address range, and a prefix also defines the network ID. So really, when you're looking at version 4, I just want to make sure I write V4 so we don't get it confused. We have a network ID and a range of